Okay, this is a video that goes with the comparing motion graphs and simulations. We're starting to look at velocity time graphs as well as the position time graphs that we've done so far. So the first thing you would want to do is open this up. This is APM, the first of the three simulations. I'm going to run it. There's the object moving from the left to the right. At that point, you'd want to pause and describe what kind of motion it is. Again, the options really are constant position, which would mean you're at rest, constant velocity, either positive or negative, which would mean you'd be moving equal amounts of space per time, and constant acceleration, which would indicate you're either getting faster, getting slower, or perhaps changing your direction. If you look at the tracking picture, that should also match up with your answer to the first part. Gapping in between those pictures should tell you something, since they're each taken at a set piece of time. Okay, now we're going to slide on back, go to the beginning. We're going to record data every half a second using the displacement quantity here, the velocity quantity here, and the time quantity here. So to start with, at time 0, we have 0 and 0 meters of displacement and 4 meters per second of velocity. Now we're going to click ahead until we get to 0.5. We can use the step forward button. Okay, there's 0.5. Collect our data, 2 and 4. Go ahead to 1 second, 4 and 4. Go to 1.5 and it's 6 and 4. 2, it's 8 and 4. 2.5, we're at 10 and 4. 3 seconds, we're at 12 and 4. 3.5, we're at 14 and 4. And finally, at 4 seconds, we are at 16 and 4. Now, if you have trouble picking up those numbers, you can go back and, of course, pause in between and pick up the numbers. You want to fill in the table, and then you'll want to use that information to calculate the acceleration of the object during this period of time. Now, depending on your description of motion, that acceleration value should be, in most cases for us, constant. Now, it might be 0 if there is no acceleration, or it might be some kind of positive number, or it might be some kind of negative number. But it should be constant the whole time. Now, for the graph sections, we have an object moving with a motion to the right. So if I click on this arrow, I can see the graph of displacement versus time, the change of position versus time. If I take the slope of that graph, I'll have the velocity. The new element we're looking at is, well, what if I just want to know how fast I'm going? What should the velocity compared to time look like? So this, again, will depend on how you've answered so far, but here's what you get. It's a flat line right at 4. Now that's going to tell you something about the motion. You should feel confident in your description at this point of the type of motion that you have here. Okay, there's some more calculations to make on the sheet. You can do that without the video, the rest of it, and then you'll be moving on to part B.